Hello everybody and welcome to another video on C programming. Today the subject of our discussion is bubble sort. So bubble sort is one of the many sorting algorithms that we'll be studying about in this session. And what is sorting? First of all, you'll need to understand what is sorting. Sorting is all about arranging the elements of an array in a proper sequence. So the sequence can either be ascending or descending order. So one of the techniques that we can use to bring about that change, that is arrangement of the elements in either ascending or descending order, is bubble sort. So let us take a look at the PDF that we have before us and let us see what bubble sort is all about. It says bubble sort algorithm for sorting of n numbers, where n is the maximum capacity of any given array, represented by an array A1 to n, proceeds by scanning the array from left to right. So we know the array, if these are the elements of an array, so the sorting algorithm will start from the left and it will proceed towards the right, that is towards the end of the array. At each stage it compares the adjacent pairs of numbers at positions ai and ai plus 1, and whenever a pair of adjacent numbers is found to be out of order, then the positions of the numbers are swapped. So you can see that if we take this as an example, so let us say that we have been assigned the responsibility to swap the elements of this array in ascending order. So you can see at the beginning, if we say that 80 is represented by this ai and ai plus 1 represents its adjacent element, so this one is 32. So you can see that 80 and 32 are out of order, because 80, if these elements are intended to be arranged in ascending order, so 32 should be before 80, because 32 is lower than 80. So in that case we'll have to swap. If it compares ai and ai plus 1, ai plus 1 refers to the element that is adjacent of our current element, and whenever a pair of adjacent numbers is found to be out of order, like in this case you can see 80 and 32, then the positions of the numbers were swapped. So what do you understand by swapped? Swap basically means their positions are interchanged. So you can see that in the next iteration, that is in the next round, 32 and 80 have been their positions have been replaced by one another. So 32 goes to 80's place and 80 goes to 32's place. So whenever a pair of adjacent numbers is found to be out of order, then the positions of the numbers are swapped, and the algorithm repeats the process for numbers at positions ai plus 1 and ai plus 2. So thus in the first pass, after scanning once all the numbers in the given list, first pass refers to the first iteration. Okay, iteration means the number of times the loop executes. So each iteration is represented by each cycle of the loop. So thus in the first pass, after scanning once all the numbers in the given list, the largest number will reach its destination, but the other numbers in the array may not be in order. So in each subsequent pass, one more number reaches its destination. So what basically happens here is that whenever this sorting algorithm executes, so if we are sorting this number in this list in ascending order, so the highest number will reach at the bottom of the list. So you can see the highest number out of all these is 110, so this will reach the bottom of the list. So the number of passes, that is the number of iterations that the loop has to execute before the list is fully sorted, is n minus 1. So if there are n elements in an array, so the maximum number of iterations that are required to sort, that is rearrange all the elements of the array in ascending order, is n minus 1. So let us take a look at the example now finally. So in the following, each line, pairs of adjacent numbers shown in bold are compared, and if the pairs of numbers are not found to be in proper order, then the positions of these numbers are interchanged. Alright, so the list to be sorted has n equals 6 as shown in the first row below. So so there are 6 numbers in this array. So let us consider these elements as the members of an array. So the maximum number of iterations, like I told you before, that means the maximum time the maximum amount of time the loop has to execute before the list, that is the array of numbers is fully sorted, is n minus 1. So if for example an array has 8 elements, so the maximum number of times the loop must execute before the array is fully sorted should be n minus 1, that is 7. So if the loop executes 7 times, then the array will be fully sorted. So this represents the worst case scenario when the array is completely out of order. So the situation may vary, the number of times the loop has to execute may vary depending on the relative positions of the elements of the array with respect to one another. So if the array is fully unsorted and everything is out of order, then it will take at least n minus 1 times to not at least, at the most it will take n minus 1 times to sort the array. So often in your exams you may be asked such questions that if there is an array of 10 elements suppose, so how much time or how many iterations the loop must execute to completely sort the array using bubble sort. So the answer will be n minus 1, that is if there are 10 elements, so the number of times the loop must execute will be 9. So now let us study the example we have before us. The list to be sorted has n equals 6 as shown in the first row. So this is iteration number 1. So as I've told you, the maximum number of iterations this loop must execute will be n minus 1, that is 5. So in each pass of the loop it will it will compare the adjacent numbers with one another, and if it finds any number that is out of order, it will interchange their positions. So first, like I have already discussed earlier, 80 and 32, these two are out of order because 32 is lower than 80, and if we are going to arrange all the elements in ascending order, so 32 should come before 80. So in the next round the positions of 32 and 80 are interchanged. So after that we go to 80 and 31, that is I plus 2 and I plus I plus 1 and I plus 2. So if this was I, this is I plus 1 and this is I plus 2. So now we are comparing between I plus 2 and I plus 1, and you can see again there is a similar problem that 80 it is a higher value than 31, so their relative positions are not accurate. So what we need to do is we need to swap their positions. So 31 goes into 80's place and 80 goes into 31's place, and after that we are comparing between I plus 2 and I plus 3. So the value of I is 0. It starts from this first index of the array, that is 0, I equals 0, and it goes to the end of the list. So this one will be I equals to 5. Alright, so 0, 1, 2, 3, 4 and 5. So this one must be if it is I plus 1, I plus 2, this one is I plus 3. So now we are comparing between I plus 2 and I plus 3 over here. So now we can see that 80 and 110, their relative positions next to one another is okay, because 80 is lower than 110, so 80 is exactly where it needs to be, and 110 is also where it's supposed to be. So their positions, there is no need to interchange their positions. So swapping will not take place in this third iteration, that is in the third round, third pass that is. And so it goes on to compare between I plus 3 and I plus 4. So I plus 3 is 110 and I plus 4 is 50. So as you can see here that 50 and 110, when you are comparing between them, 50 is the lower value than 110, so it should not be after 110. So what we need to do is we need to interchange the positions of 50 and 110. So 50 should come here and 110 should go here. And so after we have swapped their positions, we need to move to the end of the list, and now we are comparing between I plus 4 and I plus 5. So now also there is a similar problem, 110 and 40. So 110 is bigger than 40, so now we need to carry out the swapping once again. So finally, after all the elements are swapped in the first iteration, the elements of the array, they look like this. So as you can see that the array is only partially sorted. We need to execute a few more passes before the loop is fully sorted. So like this it will continue until and unless the loop is fully sorted. So let us take a look at iteration number 2. So this is the second loop, second round of the loop. And you can see that there is a very important thing that you need to notice here. So in each iteration, the number of elements that are being considered for swapping, for comparison, that is, it decreases by 1. So like I told you before, the highest element, if we are sorting this list of numbers using ascending order, in ascending order, so after the end of each iteration, the highest value will move to the bottom of the list. So here you can see the highest value is 110, it moved to the bottom of the list, that is the end of the list. So this is a sorted sublist. So if we take this entire list and divide it into two parts, this one is the unsorted part and this one is the sorted part. So the sorted part is partially sorted because only one of the elements has reached its proper position. So if we are to compare between these numbers, we can say that 110 is the biggest number, so it should be at the end, and this is where it has reached at the end of the iteration. So 110 has reached its proper position, so we need not include it in other subsequent comparisons. So when we are going to compare between the remaining elements of the array that have not yet been properly sorted, we can exclude 110 from further comparisons because it has already reached its proper place where it is supposed to be. So in each subsequent iteration, so in iteration 2, 3, 4 and so on, so one element successively will decrease from the number of elements that are being compared. So after 110, 80 is the next highest element, so it will reach the second highest position, so it will reach position number 4. So after that, after the end of round 2, 80 will be removed from further consideration and we will only be comparing these first 4 elements. Because they have already reached their proper position, their intended place in this list, there is no need for us to include them in other subsequent steps, subsequent comparisons, because they have already reached their proper goal, that is the place there where they need to be. So in other subsequent iterations of the for loop or any other loop that you might be using to sort your array, these elements are no longer needed to be compared. So I skipped a couple of pages, let me back up. So here we have iteration number 2. So 110 has been removed for further consideration. So we'll only be comparing 32, 31, 81, 50 and 40. So like we did, we'll proceed in a similar manner like we did before. So we can see that 31 and 32, these two are in their proper positions relative to one another. So there is no need for us to swap them. Next we compare between 32 and 81. These are also in their proper places, so there is no need to swap their positions. And after that we are comparing between 81 and 50. So now there is a problem because 81 and 50, these are out of order. 50 needs to be before 81 and 81 needs to be after 50, so their positions are interchanged. So after this we are going to deal with 81 and 40, and they are also swapped. So finally at the end of this iteration, 81 reaches its proper position. So this sorted sublist, which initially consisted only of 110, so this now another element is added to this sorted sublist, which is 81. So this sorted sublist currently has two elements, 81 and 110, and this unsorted sublist will have the remaining 4 elements. So 81 and 110 can be removed from other subsequent iterations of the for loop. So this will go on and on until it reaches the 5th iteration, and these are already sorted like this. So now let us take a look at the code for bubble sort. So let me pull up the code here before you. So here we have bubble sort, the code for bubble sort. So we have divided this program into several functions, and each function performs the designated task. For example, this input array function, it accepts a number into an array. So let us study the program and see what it does. So first of all, let me start from the main function, because that is the main program from which other functions are being called for execution. So here we have some variables opt, a20 and n, and we are providing a menu driven program, that is we are providing some options to the user. So the options are being included in the form of switch case. So first of all, we are giving the option to the user to perform bubble sort, and the second option is to quit. So number one option, bubble sort, it corresponds to case 1 of the switch case construct. So if the user enters the number 1, so it will automatically go to case 1 and it will execute all the steps needed for bubble sort. And if the user chooses to terminate the program, he will enter 2 and then the program will exit. So let us concentrate on this case 1. So let us assume that the user has pressed 1, that is he has selected the first option. So first of all, we'll need to enter the length of the array, that is the total number of elements that we want to include in our array. And after that, we'll have to invoke this input array function. Okay, so let us take a look at this input array function. So this input array, here it consists of an array by the name of a20, and n represents the maximum number of elements that are present in the array. So we are starting from 0 and we are going up to n minus 1, and we are accepting all the elements in the array from the user by using a scanf function. So we are entering numbers into the array using scanf. So whenever we are calling this input array, whenever we are writing this program, name of this function and the parameters in the bracket, what happens is that from the main function this input array function is called, and this array a, which has been declared in the main method, and the total number of elements n, these are passed as parameters to this function. So you can see that this function takes two parameters, this array, an integer array, and a separate integer variable. So this array gets copied to a20, and this variable n, this gets copied to this n. So the number of elements that are included, that the user wants to include in the array, these are entered into the array in this step. Okay, so let us now move on to the next step, which is printing of the unsorted array. So before we perform our bubble sort, we need to take a look at what this array looks like in its unsorted state. So this function is performed by this print sorted array. So print sorted array also takes the array elements, array itself as the parameter, along with the number of elements that we want to include in the array. So we are printing the elements that we entered in the array using this input array function in this step. So the loop, like before, is starting from 0 and it's going up to n minus 1, and it is printing all the array elements separated from each other by three spaces. Alright, so for that particular reason we have given 3D, so that the elements do not appear next to one another. When the elements will be printed, they appear from each other, not in close proximity, but in gaps of 3 spaces. Alright, so that they look easier to the eye and more organized. So here there are two printing functions. One is to print the unsorted array before the sorting actually takes place, and another print sorted array function to print the array after it has been sorted. So now after this step we'll execute bubble sort an. So during this, when we are invoking bubble sort function, we are passing the array a as the parameter, followed by the total number of elements that we want to enter into the array. So bubble sort function, here we have defined the bubble sort over here. So after printing the unsorted array, we need to perform the actual sorting. So the algorithm for sorting, or the steps for sorting, will be performed in this function. So here also we are passing the array, this array a. So this array a is passed as a parameter to this function, followed by the number of elements. So array a and the number of elements are passed as parameters to this bubble sort function. And after we have started this function, what we are doing is we are executing nested loops. So we are executing one for loop inside another for loop. The reason for it is that we need to mm, go through. So we need to, there are two loops actually. The outer loop, you can see it goes from 0 to n minus 1. Like I told you before, that if the size of the array is n, so the maximum number of elements, so you can see that the size of the array here, it has been assumed to be n. So the maximum number of steps the for loop, or the any loop, whatever loop that we are employing in our program, it needs to execute before the array is fully sorted will be n minus 1. So as this is starting from 0, it is going to n up to less than n minus 1. So essentially it's doing the same thing. It is executing n minus 1 steps, and inside this for loop, let us consider this loop as an I loop, because we are using the program counter I over here, that is the loop counter. So inside this for I loop, we are using another for j loop. Alright, and this is the loop that is actually responsible for comparing between these adjacent elements and performing the sorting. So I loop runs from 1 to n minus 1, and this j loop, it actually compares between the adjacent elements and perform the sorting wherever needed by interchanging them. So you can see that, let us take a look at these comments over here. So with every step, the highest element of that step settles down at the correct position, that is at the end of the array. So we need not include it in the next step. And here there is another comment line next to this j loop, for j loop. It says, as I increases in every step, number of comparisons decrease by 1. So like I told you before while instructing you on this program code, so you can see here that every time the iteration finishes, the highest number from those group of elements, it goes to the bottom of the list. So this essentially constitutes the sorted sublist, and after this list is fully sorted, after the highest number reaches the sorted part of the sublist, it can be excluded from other subsequent steps. Alright, so when it goes to the next iteration, that is the next round of the for loop, this 110 is excluded from further comparisons. So we are going to confine our comparisons to these remaining 5 numbers. So after the end of this step, 81 is the highest number out of all these, and this reaches the bottom of the list, and so this is added to the sorted sublist. So after 110, 81 reaches its proper position. So 81 and 110, they reach the bottom of the list, and after that it is also removed from further comparisons. So how this is being implemented here, let us take a look at this. So what it does is, to achieve this, we are executing this j loop like this: j equals 0, j less than n minus 1 minus I, j plus plus. So this essentially means, as every time the value of I increases, so every time the value of I increases, the number of comparisons decrease by 1. So when the value of I is 0, the number of comparisons will be n minus 1. When the value of I is 1, the number of comparisons will be n minus 2. So what it essentially does is, it removes one element from comparison from the end of the list. Alright, so when its I's value is 0, it will compare all the elements up to n minus 1. So if this represents the n minus 1 position, so all the elements leading up to n minus 1 will be compared. But after it has executed one iteration successfully, so the value of I will become 1, and in the next step, n minus I minus 1 or n minus 1 minus I, it will remove the last element from comparison, and it will confine the comparison to the remaining elements. And so every time this value of I increases, one element decreases from the comparison being performed. So in the next step, so the value of I is 2 here, so n minus 1 minus 2 will give us n minus 1 minus 2. If the value of n is 6, so 6 minus 1 is 5, 5 minus 2 is 3. So like this, it will remove one element from comparison in each subsequent step of the iteration. and if the adjacent, these aj and aj plus 1, these refer to the adjacent numbers in the array. So you can see that there are two numbers, this and this. So if we take this as an example, this is aj, and here in this in these class notes you can see that they have been referred to as ai and ai plus 1 and ai plus 2 and so on. So if we consider these comparisons as being taken place inside this j loop, so this first element will be aj, and the next element, the element next to it, will be aj plus 1. So this 80 will be aj and this is aj plus 1. So this inner loop, this aj and aj plus 1, these what it does is it compares the adjacent elements. So these two adjacent elements represented by aj and aj plus 1 respectively, they will be compared, and if they are found to be out of order, that is if aj, value of aj, which is the first element, and aj plus 1, which is the adjacent element, 32 in our case. So here you can see aj, which is 80, and 32 which is the next element after 80. These two are out of order, so we need to interchange their positions. So the swapping only takes place if aj, that is the first number, is bigger than the number next to it. For example, in the case of 80 and 110, this aj here, if we take 80 as aj, aj is the current element and 110 is the element adjacent to it. So 80 is actually lower than 110. So in that case aj is not greater than 110, aj plus 1. So in this case the swapping will not take place. So in case aj is greater than aj plus 1, like in the first step of the first iteration, so the values will be swapped. Alright, and like this it will continue until the loop is fully sorted. And after we have performed the sorting by invoking this bubble sort function, we'll print the sorted array by invoking this print sorted array function. So there are actually 4 functions. So to reduce our workload, or to make the array, to make the program look a lot more organized, what we have done is we have divided the code into several modules or several functions, and each function performs a designated task. So the input array function accepts number into the array. Print unsorted array function, it prints the array before actually perform the sorting, to give an idea to the user of what the array actually looks like before it is sorted. Now bubble sort actually performs the sorting, and print sorted array function, it prints the array after it has been sorted. So let us take a look at this print sorted array function once. It is similar to the unsorted array function that we had seen before. So this takes the array as the parameter, followed by the number of elements that are in the array, and it executes the loop that starts from 0 to n minus 1, and it prints all the elements separated from each other by 3 spaces. Let us now run the program and take a look at the output. So compile and run. So here there are 2 options. So I'll select the first option, that is bubble sort. So I'll take 6 elements. So let us use this example, and let us enter all the numbers that are shown in this example. So first of all, the number that we'll be entering is 80. So we'll be entering all the numbers that have been demonstrated in these given examples, and we'll check whether the algorithm is working properly or not. So after that we have to enter 50 followed by, it is 41, so it should be 40. So after sorting, the elements look like this. Before the array elements are sorted, they look like this: 80, 30, 32, 131 and 110. they are appearing next to one another, there is no gap between them. So 31, 110, 50 and 40, but after they have been swapped, they are appearing in proper order. So it is after the array has been sorted, it is once again it is showing the option to execute bubble sort or to quit. So now I'll select quit. So once I select quit, what happens is that this while loop, it gets terminated. So you can see that in case 2, it exits the program using exit 0. So whenever we are selecting the second option, that is quit, it goes to case 2, and after that it terminates the program by executing this exit 0 statement. So this concludes our tutorial on bubble sort, and we'll be studying other sorting algorithms in our subsequent lessons. So that's it for now, and have a nice day everybody. Take care.